Welcome to our next complex numbers video. We're going to chat about the remainder and factor theorem, and there are two videos that go next to each other and are needed in conjunction. Alright, so let's get into the first one. A polynomial is an expression with many, that's what poly means, terms, that's the word nomial. We are primarily looking at polynomials with one variable raised to a different power. We've looked at cubic, where we have x to the power of 3, quadratic, x to the power of 2, and linear, which is x to the power of 1. So we talk about the degree of the polynomial is the highest power of x. So cubic is a degree of 3, quadratic is degree 2, and linear are degree 1. Now, polynomials can often be written in factored form, so we can put it into factored form, or we could expand it out into expanded form, which is also often called standard form. Remember, a factor is a number or expression that divides into another number or expression exactly without leaving a remainder. For example, 4 times 9 is 36, so 4 and 9 are factors of 36. Just like x minus 13 times x plus 2, x minus 13 and x plus 2 are factors of x squared minus 11x minus 26. So if I took 36 and divided by one of my factors 9, I'd get the other factor 4 with no remainder. Just like if I took x squared minus 11x minus 26 and divided it by one of the factors, x minus 13, I'd get the other factor x plus 2 with no remainder. Right, to determine factors and remainders of polynomials, we're going to utilise two simple theorems called the remainder theorem and the factor theorem. Here's the factor theorem and here's the remainder theorem. Now, I've simplified it. It's a bit more complicated than what I'm going to explain right now, but basically I'll try and make it pretty simple. If a polynomial, if we substitute a value of a into a polynomial p and we get 0, then we know that x minus a is a factor of the polynomial. And if I went to divide the polynomial by my factor, I'd end up with no remainder because it's a factor. If, however, I substituted the value of a into a polynomial and I did not get 0, then we can say that x minus a is not a factor of the polynomial p, and when I take the polynomial and divide it by x minus a, I end up with some remainder. Now, it's quite complicated, so let's see if I can explain this with some examples. Here's an example. We have a polynomial p, which is x squared minus 11x minus 26. It's a quadratic. And we can put it into factored form, x minus 13 and x plus 2. If I took the polynomial x squared minus 11x minus 26 and divided it by one of the factors, I'm going to come up with the other factor and there'd be no remainder. For example, I took 14 and divided it by one of its factors 7, I'd come up with the other factor 2 and there's no remainder. If I took the polynomial x squared minus 11x minus 26 and divided it by the other factor, I'd come up with the factor of x minus 13 with no remainder again. So for example, I took 14 and divided it by the other factor 2, I'd end up with the other factor 7 with no remainder. I took x squared minus 11x minus 26 and divided it by a completely different expression or different number, I'd end up with something else, but I would have a remainder because x plus 4 is not a factor. It's like if I took 14 and divided it by 5, 5 is not a factor of 14, and I'd end up with 2 whole and a remainder of 4. All right, we're going to stop there, and hopefully you have time to move straight into the next video. So thanks for watching.